Hi, welcome to the continuation of our fluid mechanics videos. And today we want to talk about manometers. Now I assume you should already have some kind of experience with it. And we find that, okay, the pressure here should be equal to pressure here. This should be pretty straightforward and part of the prerequisite knowledge. But just cause, this is just a recap of how it's supposed to read manometers in case you really don't know. If you already know, you can skip, and if you're not interested in seeing some of the example problems for exams, you can also skip. So I took this from Perry's, as I was saying before, and yeah, to read we'll just draw. Okay, I'll have one straight line across here at this. Oh, yeah, that's better. Straight line. Okay, and I'll say the pressure here equals to the pressure here. It's supposed to be straight. So what's the pressure at point 1? The pressure at 1 equals to, it's just the pressure at 1. So since the pressure here equals to the pressure here, so here it will have the pressure at 2. Okay, plus rho gh gz delta. So rho g delta z of this dark colored fluid. This is of course assuming this assumes that the pressure in the fluid is negligible, or rather density of flowing fluid is negligible compared to P1, P2. Okay. Of course, if this flowing fluid was water and this dark fluid is mercury, then you may want to factor in some of the fluid height from here to here. So I'm going to draw. Okay, we're going to draw a line from here to here, and then we'll want to consider the fluid height here and the fluid height here if the density of this flowing fluid is not negligible. Okay, so we'll just add the rho g, this L1 and this is L2. Okay, if the fluid height is not the fluid density is not negligible, then I'll just write rho L, where rho L is this fluid density, not this dark fluid density, is different, GL1, and here I'll just write rho GL2. Now that's it. Okay, so this is the basic idea, how we want to read manometers. Okay. Yeah, if you don't want to look at the example problem I'm going to find on the internet, and just forget it. Otherwise, you can continue. So now is the example problem we want to look at. And what is this example problem like? Well, I took it from this website here. Quick Google search, we'll find that it will have this kind of a manometer problem. Examiners love to give it, and when people see this in exam, you get, oh, so frightened. Yes, that's very understandable. That's why I want to go through some of how we're going to do this. So first thing first, we want to break this problem down into some sections. So I'm going to draw a green line. Okay, and I'm going to draw a red line. Okay, so I'm not going to take a look at this portion. I'm not going to take a look at this first. I'm just going to take a look here, okay, where I'm circling. So gonna copy and paste. Alright, so let's consider the mercury pressure balance. Okay, the mercury, so the left side. So what is over here? We have 20 cm, so all these are in cm, centimeters. 20 centimeters of benzene plus Pa, plus 20 cm times G times rho benzene. Okay, so what's over here? Here we have some mercury, which is 8 cm of mercury. So let's write 8 cm times rho merc times G plus there's some kerosene here. Now, what is the height do we want to compare? Well, if we take a look, there is this line here where there's some water, and we can use this as some sort of reference point. Okay, so I'll just quickly go through this example. So we can use this blue line here as a reference point. The blue line here will be a reference point, so we will have, here's 40 cm, here is 8 cm, so there is 32 cm of kerosene. So I'm gonna write 32 cm times G times rho kero. Is that the end? Not quite. There is over here, there is some pressure which we don't know, so I'm just going to call the pressure at this blue line P kero or P blue. Okay, P blue, and we're going to paste this equation here. That's for the left hand side. Now what is the right hand side? So we have 40 cm of water plus P blue. So if you look at this red line here on the water, it's going to be 40 cm plus this P blue, whatever is at this blue line. So P blue plus 40 cm times G times rho water. So this is this side. Then we will have 14 cm of water plus Pb equals to 14 cm times G times rho water plus, oh, PA, I mean, sorry. Oh, PB. This is PB. This is PB. Okay. So if we just subtract this out, we'll minus 14 G and rho water and both sides. Just get 26. So 14 minus 40, that gives us 26. Okay. So that will have PB. So how do we find PA in terms of PB or PB in terms of PA? Whichever. Now we see this equation I'm highlighting in blue, and this one I highlight in green. So we see that P blue is represented at both sides. So I'm going to solve these two simultaneously to get PB and PA in the same equation. Okay, so okay. Alright, so I've rearranged to find P blue, and I'm going to write P blue here, or rather copy and then I'll paste. Okay. So if we have exam problems, we want to find some of these missing pressures or some density in terms of these pressures, we can use this equation quite simply. And that's how we kind of solve what we want to find. let's say if you want to find what PA is, we shift everything over here. Now, of course, I made an assumption because, you know, the density of air is like 1000 times less than water. So I did not include this 9 cm of air as well. Now, if you want to include that 9 cm of air, if the air is very, you know, dense for some reason, which it should not be, we usually neglect the density of air in comparison to liquids. Yeah, we can do it as well, but we'll see that it doesn't change the answer much. Therefore, we neglect it. Okay, and that's all I have for you on manometers. So we have gone through, you know, a refresher course on how we should be reading manometers and one so-called example problem. And that's all I have for you this video. See you next time.